people say the science itself is neutral. It's how society decides to use it that makes all the difference.
Welcome to Radio Davos, the podcast that looks at the world's biggest challenges and how we might solve them. This week, we are looking at the top 10 emerging technologies that are set to change our lives for the better.
It may be something that's in stealth mode. It may be something that is a very limited distribution or knowledge of, where it just turns out to change the world.
We're looking at breakthrough tech, but we are not looking at bells and whistles and just the whiz-bang of it all. We are looking for something that is going to have meaningful change and impact.
We look for weak signals that, in the noise to find out what's going to advance. These things tend to build. The world's problems are complex. They have built up over many decades, many hundreds of years in some cases, and solving them is also a bit complex. So how do you get ahead of that? Well, you have to keep an eye on what's coming up over the horizon and make plans so that those things that are coming up over the horizon can be dealt with in a collaborative and synergistic way.
This is the 13th year that the World Economic Forum has published this special list and report. I am Linda Lucina, and I am guest hosting for Robin Pomeroy this week, as our esteemed report co-authors are based here in the States. For the fifth time on Radio Davos, I'm very excited to welcome Mariette DiChristina. She is the Dean and Professor of the Practice of Journalism at Boston University College of Communication. How are you, Mariette?
I'm awesome tonight. So glad to be here.
Wonderful. And Bernie Meyerson. He is the Chief Innovation Officer Emeritus at IBM. How are you, Bernie?
Doing well.
So we'll get into the guts of the report in a minute, but I just wanted to set a little bit of the stage for folks who are watching this and who will be listening to this later on. We do the report every year. We're looking at breakthrough tech, but we are not looking at bells and whistles and just the whiz-bang of it all. We are looking for something that is going to have meaningful change and impact. I wanted to get a sense from you both. You think about meaningful impact in the long term all the time. Do you think most people are thinking about the long term when they're thinking about tech, or are they thinking about the hype in the short term? What is your take?
It's a challenge. The challenge is that it's extremely difficult to look long term unless you have some level of expertise in what you're discussing. So there is a natural tendency to some extent, to be not a victim of, but somewhat victimized by the hype that's out there. The good news is that there are bodies like the World Economic Forum that actually sort through that hype and say, look, what really matters? So it's very hard to get folks to look very long term unless they're in the field, and then it's their obligation. The trivial example being you build a nuclear plant. It'd be really good to know 30 years from now what you're going to do when you're disposing of all the waste. That kind of foresight is critical if you're actually in the business.
And when we're talking about the report itself, can you both tell me how it was put together? A lot of folks maybe don't realize everything that goes into selecting this, to screening this. What goes into selecting these 10 standout technologies?
Yeah, thanks for the great question. I'm going to have to look down once or twice because there are many steps. I hope you don't mind. Multiple steps involving literally hundreds of experts. And still, at the end, as Bernie will confirm, it's a bit hard to choose, and we'll talk about that later. But first, we start with a survey to the World Economic Forum's Global Futures Council's network and the Frontiers Chief Editors, which is a partner, and the Top 10 Emerging Technologies Steering Group itself. And the technologies may be entirely new, like we haven't really heard about them before in the lists in the past, or maybe they're a really innovative way of applying an existing technology. And we had about 250 or so submissions this year that were verified technologies. We used an AI trend analyzer by Frontiers, which mapped the trendiness score based on a variety of factors. And then the World Economic Forum's Resilience Consortium's Resilience for Sustainable Inclusive Growth Framework was applied. And last, not least, we look at business funding behind each of these. And then, of course, the criterion for the top 10 emerging technologies. What is their level of novelty? How impactful could they be? And what is the depth of them? How many different parties are involved? Does it seem like it's more than just one company doing one thing?
And then to be honest, there's a gut feeling. So you place a bet, which is it has such an enormous potential upside that even though it's not well known because it may be something that's in stealth mode, it may be something that is a very limited distribution or knowledge of, where it just turns out to change the world. The example, for instance, being CRISPR-Cas9, which back when we identified that as a team was almost unheard of. So if you did the typical analysis and said how much investment, how many people are out there doing it, it's a tiny number. But it enabled phenomenal things going forward, some of which, to be honest, we're still benefiting from today. mRNA vaccines, the transplants recently of organs from other species that, frankly, have been changed to be compatible with humans. None of that would be possible. So there is an element of just trusting the people you have on the committee to see things that are just foundationally differentiating, that they're worth the risk.
And I think it is important to note that those were all technologies that had been identified in past editions of this report, which kind of gives a sense of the little weak signals that the report listens to and that all the experts listen to, that down the line can show that there's a real trend and that there's real potential and possibility. Well, why don't we get into some of the cool tech that we have? I'm very excited to start with structural battery composites, which doesn't seem sexy, but when I was reading about it, it is very, very cool. Tell me a little bit about it and why is it so cool?
One of the reasons that it's interesting is if you think about EVs today, they actually have the first very crude version of structural batteries. And what I mean by that, the actual batteries are these little tiny cells that would make this look big, thousands of them inside a box. And the battery itself, however, is a rigid element to protect them. So what they do is they actually use that rigid frame of the battery to actually help support the car, literally hold it together quite straightforwardly. That, unfortunately, is not very efficient because there's a whole lot of excess material and the weight associated with it is very large. Imagine, though, that you come up with different materials that are based, for instance, on spun carbon fibers and different electrolytes, so that all of a sudden this battery that literally weighs a ton or more suddenly becomes half that weight. The differentiation in terms of the amount of energy it takes to push the car or to fly an aircraft, if you're equipped with these batteries, is spectacular. So there's an enormous potential upside, and people are working on it. So they would literally make, for instance, panels, flat panels in an aircraft where the panel actually is a battery. And you would integrate that with the aircraft so it would serve dual function. It is part of the aircraft, but at the same time, it's the energy storage system. Same thing with a car, same thing with virtually anything that utilizes energy. So it's an area that is evolving. It is early in the cycle. But the fact of the matter is that there's been enough progress, enough pressure because of the intent to eliminate, for instance, internal combustion engines to the extent feasible, that people are driven to actually do this work. And it looks quite promising, quite actually, based upon progress made in materials.
And this report, of course, we're looking at sort of what is the big strategic thinking that people should be applying. How is this really going to be changing? What's the before and after? If we are changing transport, if we're changing aviation, what does that look like? How is the world different maybe in 20 years, 30 years, if this is more common?
If you think about it, if you're able to store energy, a much higher amount of energy at the same weight, then the issue where people have range anxiety. I love it. They've created a new disease, range anxiety. Okay. What that has to do with the fact is you've got a battery-powered vehicle, you're motoring along, and what if you run out of charge? Well, imagine that if you were able to reduce the weight of the battery by a factor of 2, so you could literally, for the same weight, put in twice the energy. Well, there's an interesting option because suddenly the car has a range of 600 miles. I don't know about you, but I really don't want to sit in it that long. So it changes that. And the other thing is aviation. There are currently vehicles, electric vehicles, that are being flown. They do not have anything but batteries. Being able to lighten them dramatically is crucial to electronic-driven aviation for it to work. So, yeah, it has the potential to actually sort of rewrite the range and script on those.
Mm-hmm. Our second technology on our list is osmotic power systems. They channel salt into energy. Can you explain a little bit more about how that technology works? First of all, why don't we just start with that?
Well, it makes use of the fact that if you actually separate very salty water from water that is not as salty, that actually gives you the opportunity to drive energy by putting a membrane between them. It's called an osmotic membrane, where very naturally the Earth tries to reach equilibrium, which is a fancy way of saying if you've got a lot of excess water on one side and a lot of excess salt water on the other side, the water will migrate over to the side with the salt to dilute it till we get the equal amounts on both sides, the equal salinity. In doing so, though, it generates pressure because water is moving across the membrane. You actually have excess pressure on one side. And the moment you create excess pressure, you can use that as one example to drive a turbine. So that is one example. That's physical. There's a whole nother version of it where if you have disparate amounts of salinity, and it's easy to get it. If you have a plant that does desalinization, it takes the salt and separates it out of water, which means the little bit of water that's left behind has a tremendous amount of salt in it. And you can draw water in from a lake or an ocean that does not have as much. You actually can put a membrane between those two bodies of water that actually allow the separation of the actual ions in the liquid, so that the negative ones go to one side and the positive remain on the other, as an example. That's how a battery works. You literally create charge by having the right membrane there, and you can use it to draw electricity right off of that. So there are two very different approaches, one of which is you're generating pressure and using excess pressure to drive a turbine. The other is you literally are just separating the ions that naturally occur, because when you dissolve salt, it's sodium chloride. You get sodium ions and chlorine ions, and depending upon which way they go, you can actually move charge to opposite sides of a membrane and use it as a battery.
And as the report mentions, we're merging both energy and sort of water resource management with this. But what I thought was really, really interesting about this is that there's the opportunity to rethink how we're using water at all with this. Can you talk a little bit about that and about the shift in mindset that this technology will could make commonplace, which is that water isn't just something we use up, which unfortunately has been the reality for many, many centuries of mankind, and could be something else. Can you talk a little bit about that?
Well, we basically recognize the criticality of pure water. There is a limited amount of that in the world, and frankly, it's being utilized faster than it normally is naturally generated. So the real issue we're up against is we want to make absolutely sure we make the best use of it possible. The interesting thing is that if you can actually take all of the energy that went into, for instance, desalinating water and creating this super rich, concentrated water, which has lots of the excess salt you took out of the clean water in it, to be able to then recover some of that energy by then using it to run a battery, it's a virtuous cycle. And that's something, again, the World Economic Forum has emphasized, is the ability to have sort of a circular economy where on the one hand, you're intentionally pulling salt out of water and creating really, really super saturated water with tons of salt, energy use. But then the flip side of it is you then use that to create a battery, which actually reduces the salt content by turning it back into energy that you use to run something. That virtuous cycle, that circular economy, is something that we really need to think of in terms of our natural resources, which are finite.
And gives a strategic impetus and sort of a business impetus for the circular economy, which is much needed.
Exactly.
Absolutely. We also have really interesting for our number third technology, advanced nuclear technologies. Folks are familiar with nuclear energy, but what is new? What is changing with this? Can you talk a little bit about that?
For many, many years, decades, the nuclear reactors have tended to be bespoke, which is to say you literally pick a site, you build a reactor there, you adjust the size of it and all that. The trouble with building what we call one-offs is there's always the opportunity, as standard as you try to make it, to introduce new issues that can be problematic. What people have recognized is there's an entirely different approach you can take, which is what would happen if we just designed small modular reactors that you literally could build in a factory and they're all the same, so that you had this economy of scale you've never had before, because you literally are building reactors that might be 1/10, 1/3 the size of everything before. And yes, if you need a lot of power, fine, put 5 of them in one spot, but they're all identical, which means the odds of a problem, the odds of an error, the cost of doing it, all of them are improved. So it's really a very different approach from what had been from the precedent. That's one. Two, people are also rethinking how you make a nuclear reactor work. There are some very, very novel designs where instead of running high-pressure liquids through a system and then having to worry about does the liquid become radioactive and all, there's some unique designs in use today, in fact, that, believe it or not, are just flowing inert gas, helium, over a bed of little pellets of uranium that get really hot. And what they do is they take that helium and they circulate it and take the heat out of it. And elsewhere, they basically transfer that heat to water and boil it and run turbines. Here's the good part about that. If the helium gets loose by whatever failure, it doesn't matter. I mean, other than the fact that you would talk and squeak like a bird, the reality is that you can vent it to the atmosphere because it doesn't become radioactive. That's hugely important in differentiating. And so people are experimenting now with very novel and inherently safe designs. And as a consequence of that, nuclear energy has a comeback, largely because, to be frank, it is one of the essentially zero carbon sources we have that is also very energy rich and is constant. So that's one part of it. The future, the far future part of it, which we have to speak of because it would be foolish not to, is people are working feverishly on nuclear fusion, which has some enormous potential because basically if you fuse two hydrogen atoms, you get a vast amount of energy in the form of what's left over after you make a helium from that. There is an enormous challenge technically to make this a stable process because it has to run roughly at the temperatures found inside the sun, which is no small feat. But people are getting astoundingly close to this. They have not generated net positive energy yet, but they have successfully caused fusion. And the reactor designs today, there are countless reactors now built around looks like an overgrown donut. They call it a tokamak, where people are now progressing that as well. So nuclear energy, in spite of some very early issues that clearly you cannot ignore, nonetheless is making a significant comeback by people paying very careful attention to how we execute it.
And what's the before and after? So for people who maybe don't really understand how the world might change, what does it look like? Why is this so critical to do?
The criticality comes from the fact that there is such a massive electrical demand today that these coal plants that normally were going to be shut down are continuing to operate, generating tens of thousands of tons of carbon dioxide into the atmosphere and driving global warming at extraordinary levels. If you have something available that is energy dense, like nuclear energy, as opposed to those, just by doing so, you dramatically reduce the amount of carbon dioxide released into the atmosphere and the global warming impact. So that's a before and after that are actually incredibly valuable. And it can basically, you have enough demand today with the advent of AI and a shift to electric vehicles that we have to find additional means that do not pollute the atmosphere as we're currently doing today. So the before and after this is one of those methodologies that would accomplish that.
You mentioned one of the things that could hold it back, which is that trust piece, right? People want to make sure that this is safe. As with all the technologies here, that's always a consideration. But I guess the other question that I would have, and it's mentioned in the report, will we have enough nuclear engineering experts in order to make this possible? What is the status there?
That is a challenge in all fields of sciences. Right now, if you were to ask me that question bluntly, my answer would be no. I mean, let's be very honest. The challenge we have is when fields fall out of favor. There was a period of time after some of the issues with Chernobyl and issues with 3 Mile Island and later with Fukushima that people were not engaging in studying for nuclear technology for the simple reason that no plants were being built. Literally none. There was a long dead period of 10, 20 years when there were no plants created. And if you look at the graph, it's frightening. It's flat. And as a consequence, people don't pursue dead areas. It is no longer it is a vital need at this point. And my hope is that that's recognized by technical universities and we actually increase enrollment and attract people back to this. The good news is that the small modular reactors that people are now developing have actually attracted quite a bit of investor interest and quite a bit of interest, frankly, in the technical community. And when that happens, usually students pick up on it. So my hope is right today, probably we're well short of what we could need, But I would say in 3 to 5 years, particularly as these are licensed, it will grow to be sufficient.
Our number 4 technology is engineered living therapeutics. So why don't we talk a little bit about this? These are really, really interesting. They're microbes designed to deliver therapies on demand. Can we talk through this? How does this technology work?
Yeah, love to. So first of all, this is an outgrowth of synthetic biology, which is something that's been coming down the pike for a long time, where you can rewrite a piece of code and insert it into the organism. And I should back up and say, you said microbes, so this could be bacteria, this could be fungi, this could be even viruses, anything that can run a piece of instructions. I mean, the analog to computing isn't totally wrong there. There is instructions that the DNA provide, and that these little factories then can produce. And today we use a version of this, and that we use some engineered organisms in factories to help produce some of our therapeutics or medicines. But down the chain, we have to purify them, we have to test them, we have to do a lot of packaging and then getting them around, such that it costs about 70% of the entire creation and distribution process just to do all that purification down the line. But what if you could engineer these organisms so that they could be internal factories to use, so that once they've been engineered and then implanted, they could continuously provide medication. So imagine, you're going to ask me what could the impact be like. Imagine a diabetes patient, and there are so many millions in the world who suffer from this chronic disease, where they continuously have to monitor, make sure that their glucose levels are okay, and then apply additional glucose if that's needed to stabilize what they have in their bloodstream. Well, imagine if you had engineered living therapeutics, these little biofactories inside of you, and they could supply that glucose as needed by the body. It'd be more like what your body would naturally do if you didn't have that illness.
So, in other words, something that can revolutionize both the patient experience, right, as you're saying, right, but maybe also just how we deliver drugs, the cost of these things, and also, as a result, the access to these therapeutics and to these treatments.
I mean, absolutely. I mean, think about medications that are being transported. I mean, everybody's had something that you have to keep in the refrigerator, let's say, or something that's only shelf stable for a period of time. Well, now imagine that it's made in a central location and shipped around the world. You can't control the temperature perfectly all the time. You can't control the situations that the medicine's going to encounter. But what if you can distribute those, because they can be applied, more locally? Then the access is better. You're paying less money for the cost of transport, which is also beneficial to the environment, and making that medicine more available and more reliable when it is delivered, because it's right there. And there are quite a number of companies working on these therapeutics for a bunch of different illnesses, from cancer to, I mentioned diabetes, even for potentially hangovers. So it seems like quite a range. This one's a fun one to me.
Sure. Now, of course, a technology called engineered living therapeutics is going to have people sit up a little bit straighter. What are the things that people should be, as leaders, are making sure that this is safe, that we are approaching this in a responsible way? What needs to be put in place? What are the frameworks and things that need to still be built and sussed out?
Yeah, so I'm so glad you raised this, because, of course, the technology itself always needs the right context, as we were talking about in the beginning. Safety regulations, safety protocols, because anything that's engineered, you don't want just loose in your environment. You want to have regulations, too, that people have to comply with, so that they are producing them in a safe manner. So these are some things to consider. Also, going to think about what are long-term effects. What are, how is the global distribution best managed? But particularly on the regulatory front, that's something that often lags with any new technology, because the technologies keep happening and they're bubbling along, and the regulations then have to catch up.
Are there unexpected impacts that will come down the line if we have this in place, say 20, 30 years down the line, this magical world where we mentioned all these other things will be in place? If we have these engineered therapeutics, how will the world maybe be different?
People might be living longer. Chronic conditions like diabetes or even cancer might be being managed internally without you even having to think about it. And then if you combine these sorts of engineered living therapeutics, it's quite a long mouthful, I realize, but if you combine that with wearables, wearables that can detect levels of different chemicals in the body or different agents in the body. You can end up having a continuous monitoring and response system that means that, I mean, if I think about it, Linda, the world already, there are a lot of biological and ecological processes, and they kind of happen. Bernie was talking about salt and how it moves. There are increasingly human-created responses to problems in the world that are integrated into our systems. So one way I think the world could change, to answer your question, is we're thinking about it less, but it's happening because we've built it correctly. It's happening naturally. That makes us live longer, healthier lives, and that's the goal.
Question I might add to you is in terms of ecosystem readiness, I'm curious how you deal with the concept of these are GMOs. They're genetically modified organisms. And as you know, there's a natural proclivity to avoid them among a very huge part of the population. And I'm not making any judgment. That's just the reality.
Yeah.
So how do you overcome that?
Yeah, I mean, here's an editorial comment from me, Bernie, on that as somebody who's been, so before I was at College of Communication at Boston University, I was editor-in-chief at Scientific American for a decade and a science journalist, just for people who may not know that background. I think the first thing you do is listen to those community concerns. There is no way you're communicating if you're not listening first. And then you say, okay, you've got some challenges that you've identified. Let's talk about what's possible for research and applied technology to help you with. And let's talk about how you want that to happen. And, in science, many times people say the science itself is neutral. The basic understanding of how something works is neutral. It's how society decides to use it that makes all the difference. And that deciding starts with listening, starts with working on shared solutions together, starts with co-creating those shared solutions. In my circles, there's a technique called civic science, which does this intrinsically. It's something I've seen at the World Economic Forum for as long as I've ever been involved, where you bring business leaders, policy leaders, researchers together to talk about shared concerns. It takes a little longer, but when you implement it, much better done.
Absolutely. No need to move fast and break things when it comes to people's lives. Exactly. Continuing on our health theme, there's one I think there'll be particular interest to our watchers and our listeners. GLP-1s, but for neurodegenerative disease, right? Can we talk a little bit about this? So GLP-1, glucagon-like peptide-1 receptor agonists. We are very popular right now.
I'm so proud of you.
Yes, exactly. I wrote it down. I did write it down.
I'm impressed.
Exactly. And so these, we all know that this has become very popular for weight loss and also for diabetes management and some other things. But there's other applications that could be game changers. Can you talk a little bit about that?
Yeah, thank you. Thank you so much. Yeah, sure. We've heard of these medications. They're weight loss medications. But once in the bloodstream, they do something that is not actually common. They can cross the blood-brain barrier. Now, people who don't study brain science all the time don't know that it's not easy for different compounds to cross the blood-brain barrier. It's difficult to diffuse through. One thing that does it is alcohol, which explains the effects on your brain very quickly of alcohol. But these drugs, this medication does as well. And when it does, it can interact with the neurons, the brain cells that are in there, and also the glial cells, which are helper cells for the neuron cells. And they reduce inflammation. And inflammation is the body's reaction to various things that happen and is responsible for a lot of our poor health effects. Inflammation is connected to so many things, from cardiovascular disease, indeed, to things like Alzheimer's and Parkinson's, which affect more than 50 million people globally, and which GLP-1s, as applied to neurodegenerative diseases, could really help with.
And when we look at this, I mean, what are some of the things we have to keep in mind as far as what could either slow it down, or how do we keep it safe? What are these big factors that leaders who are considering this and working on this really need to keep at the forefront?
Well, I mean, the first thing is, remember, we're talking about an emerging technology here, and it is a drug that's being used for one purpose that's being reapplied to another. when you do any kind of drugs in any people, you're going to want to be very careful that they pass all the clinical trials. And in this particular case, while the results are promising, they're still a little mixed. So we have a bit of work to do, but it does look promising. You want to make sure that you get through not just the so-called safety and efficacy starter clinical trials, but the big scale ones that show us that, yes, it is definitely safe for these purposes. And I think you want to make sure, too, that there are no other effects that we're aware of.
Mm-hmm. Yeah, I think it is important just for people listening to this. Yes, it's not clinically validated, as we mentioned in the report. These things are still under investigation and being sussed out, all the rest of that.
Yeah, and of course, as we've, this is going to echo a theme that we will revisit often. There are regulatory changes that need to occur, too, with each new drug, each new application of a drug. You want to make sure that the regulations are following.
Is there a bigger picture impact with something like GLP-1s and working on them for Neogen that may be surprising? Yeah.
Think about how many people are affected by things like Parkinson's, Alzheimer's. I gave you the number of, more than 50 million around the world globally. But now think about not just those, as tragic as that is, not just for those individuals who are suffering in long-term memory care support facilities, who are not able to recognize loved ones anymore. Now let's talk about the caregivers and the time they need to spend that maybe they could also be spending on other kinds of life-affirming work. I mean, it's very affirming, of course, to support your loved ones. So these burdens for caregivers, and again, extend healthy lifespan, which is what we all want. As long as we're here, we want to be healthy. We want to be aware. We want to be enjoying this lovely planet that we're on.
Our number 6 technology is autonomous biochemical sensors, wiring biological sensors for real-time insight. How does this technology work?
Yeah, so what's wild about this is when we were just talking a little while ago about how increasingly our human-created, human-innovated responses are embedded in the world, integrated in the world through a variety of mechanisms. Imagine if we could get a moment-by-moment picture of an understanding of conditions in different areas. So one might be the environment, another might be the food we eat, another might be conditions in the body. These autonomous sensors can identify a target compound of interest and then using the transducer signal that it's there, and that lets us know that we need to intervene. Maybe there's a toxin in the food or something's gone spoiled. Maybe it's something in the environment that we're keeping an eye on, and then respond to it. And this idea of a world that automatically senses and is able to then respond to things that might be problems if they built up at scale is really an appealing one.
And I think what's interesting about this is that we do have sensor monitors currently. People may be familiar with them if they sort of have diabetes. They're monitoring their glucose, things like that.
Sure.
And the advance here is that, of course, as you're saying, it's autonomous, sort of on its own. And so what would this look like if we were trying to get a handle on water pollution? How does that change problems like that, or sort of the next big crisis? Do we get
you get ahead of it? One thing is you respond faster, and that's always good. But now let's harken back to our diabetes patients, and maybe they have engineered living therapeutics, and maybe they have these wearable sensors that are nearby that are able to see what the therapeutics are discovering and responding to, and then maybe it notifies you that much faster. I mean, in fact, there is, as you mentioned, there's a wearable glucose monitor that works with it. Now we're going to go to the next step of integration where it's happening automatically without the patient having to attend to these readouts and respond to them.
And as we talk about in the report, that there's sort of one of the strategic big things to be looking at is the interconnected applications of it all, right? And that we could then dig into maybe the source of the pollutant, not just knowing that it's polluted. Tell me a little bit more about that interconnected piece that kind of can help people understand how the scale and the potential of this technology.
Yeah, thank you. So our reports in recent years have been talking a lot about wireless technologies and then the data management systems that you need to be able to analyze in real time or very close to it all of these different data points that are coming in millions of different bits of streaming around. So yeah, it can help you. It can help you respond in a more integrated manner.
Mm-hmm. And what will slow this down?
we're going to have to get those data systems aligned. We're going to have to, particularly when we're talking about patient care also, privacy and security concerns about that data, crossing borders of different nations with that data. As you can very quickly see, that gets complicated rapidly, and countries have to work in concert to be able to have, so you mentioned the water example. Well, streams run from one country to another, lakes, cross lines. And we're going to need to think in ways where we can respond locally, regionally, through global interconnectedness. It's going to be vital. And there are other impacts to it too. It requires energy. It requires, again, regulations, our favorite R word today, and some level of cooperation to make the local benefits and regional benefits possible.
And stay on sensing. We have a different technology, collaborative sensing. How does this technology operate?
Well, collaborative sensing, basically, as one example, you're talking about the FCC just approved a new frequency for communications, and it's basically an automobile to everything. Now, why is that important? Well, if you really think about people and transport, it's a collaborative process. Obviously, cars, you don't want them running into one another. But at the same time, they have no means today, literally, to take advantage of that other than hyper-locally, which is a fancy way of saying you have a set of either cameras or radar on your car, and you probably try not to run into the person in front of you. That's not collaborative sensing. What collaborative sensing says, what if we have cameras virtually ubiquitous in a city? Similarly, what if every streetlight is controlled ubiquitously throughout the city? What if every vehicle communicates with a central location, again, throughout a city? Well, imagine you're coming up to an intersection. It's 2 a.m. Somebody who has been drinking, shall we say, excessively, is coming at high speed towards the intersection you're about to cross, and their light is red, and they are not slowing down. Collaborative sensing would be that the indicators on the indicators either within the automobile and or cameras would detect that person clearly being a danger to your life and limb, and would actually notify your vehicle immediately to brake and avoid the collision. That's the very basic form. Now we look more macroscopically. If you have today a set of information that says there's an accident on one of 2 possible roadways people are going to use, what happens inevitably is everybody gets off and uses the other roadway, which becomes a rather massive traffic jam. Any one of us who've driven in the region understand this. But there's only one lane blocked by that accident. In collaborative sensing, all of the sensors would interact and say, okay, your car should go to the other direction, but if you whittle down the traffic on this particular road so that it fits in 2 versus 3 lanes, everybody wins. That's collaborative sensing. Now, the challenge is think about the unimaginable amount of data that has to flow around for that to work. You cannot just dump it all to one central location. If you do that, somebody at the middle is going to have a massive headache before their head explodes. It's not going to work. So that brings up the next level, which is called edge computing, where instead of taking all the data down to a central point, what you do is you have tremendous intelligence actually out at the end of the network, and it only sends the bare bones minimum that's needed to make proper decisions to a central location, and or doesn't ever do that, but in fact realizes all they have to do is tell this car to stop so this other car doesn't hit it. These are things that currently are not in use today, but they can be. Now that's one side of it. The flip side is that is enormously intrusive in terms of where everybody is at all times, what they're doing, where they're going, and that is it is an ethical dilemma. One of the things about new technologies that we all need to be cognizant of is they get good and it's good and evil. I mean, it's just that simple. And what that means is the regulations, the regulatory bodies that actually prescribe what you can and cannot do with that data have to be rigorously created and enforced. It's not trivial, and I'm not suggesting, and nor do any of us suggest we not do this. There is an enormous benefit to society in terms of just reducing pollution, eliminating or at least mitigating dramatically the horrific death rate on highways. You're talking 25,000, 35,000 people a year killed for no obvious reason other than there was no control on what they were doing that could prevent that. This is the kind of thing that is coming, but we have to be extremely careful how we utilize it.
And when we're looking at the sort of the big picture and sort of how it will be deployed down the line, how important will this be as business leaders, government leaders look to make sure that they're up to snuff with climate adaptation, right? One of the things that this technology is able to do is better crisis response. We all know that there's more floods, there's more heat that's creating other sort of unexpected things. Why will something like this that has this robustness that can take something from a satellite down to some other subterranean sensor, why will that be so helpful in keeping people safe, keeping economies running? Why is that so helpful?
The bottom line is, if you look at, for instance, what happened this week in the U.S., you have tens of deaths because tornadoes propagated through a region causing havoc. Imagine being able to essentially say, there's a tornado on the ground. This is the exact path. We are tracking it literally to the foot from space and alerting the individuals at risk to get out of their homes and move out of the path of the incoming tornado. That doesn't exist today. But again, the whole point of collaborative sensing is literally a level of interconnectedness that does not exist today, but is technologically feasible. The really good thing about this is we need the will to deploy. The technology itself, fortunately, does exist. So yes, it's incredibly important because that's the extreme example of life and limb at risk. But in all manner of factories and all manners of industry, you have the same advantage, which is if you're looking at a production line where you're producing a vehicle, as an example, you can actually have enough connectivity that you actually do what they call just-in-time manufacturing with extreme accuracy. So you literally know I have to get a part from a plant to this point in the line to within these seconds, and you can do it if you have enough information. So it really changes things both economically at the level of an industrial endeavor, as an example, or societally in terms of just what you can do in terms of controlling at least the consequences of the environment. Very careful. You're not controlling the environment, but the consequences, yeah, you can prevent the needless suffering that we currently have.
Mm-hmm. Something that's coming, unfortunately, no matter what. Our next technology that we have coming down there is generative watermarking, which is really, really interesting. It's a little like a technological thumbprint of sorts. Tell me about it.
The challenge that we currently have is with the, how should I put this, with the quality of the generative models currently being created and with the efficacy of the large language models that can actually speak to you and have you believe that you're talking to a human, the challenge you face basically is how do you know if you are? That is, how do you know if you are talking to a human? How do you know if the product you're looking at was generated by a human? And even more concerning, how do you know if it is actually true? The challenge with AI is it has gotten so good in terms of what it can generate, in terms of pictures, where you can create essentially a horrific scenario where you put somebody's identity onto an act that you would want no part of. The problem is, how can you detect that? How can you detect if somebody is literally writing a report, except they didn't write it? They're submitting it, but it was written by AI. Well, generative watermarking, and there are many ways of doing it, is an attempt to validate the provenance, validate the origin of, whether it's an image, whether it's text, whether it's some facts. This is something that actually must occur. There are many ways of doing it. Some of the simplest, obviously, on images is at the level of pixels, which human eyes can't resolve, but computers can. Literally at the level of pixels, you write a signature into the image that says, "Hi, I'm from AI." That's fine. You can actually do that at a level that it's not detectable by a human, but it's easy to spot using a machine. Similarly, there are some tricks people have come up with where they say, in the English language, there are dozens, many times hundreds of words you can substitute for a word and get the same meaning. So what they do is they make a list of words that are like that, but they only, in an AI system, use one of each from that column. The odds of an actual human selecting the exact same mix of words Not a chance. Not a chance in the world. So you can very quickly scan the document and say, no. All of these words come straight out of this AI test. It's an AI document they're submitting as an original piece of work. There are many ways of doing it, but the vital thing now is preventing fraud, preventing the misuse of AI and the failure to identify content as being AI generated.
Mm-hmm. And if we don't do this, if this is not scaled out widely and used widely, what's the worst case scenario? What do we want to avoid?
The worst case scenario, unfortunately, is, for instance, in political life, you can literally simply make up things as to what the person you're competing against did and make it look so realistic, both in terms of the speech of that individual as well as the images that go with it, as to sink their candidacy and or promote your own. I mean, this is a wild west we're currently engaged in because we're getting there rapidly and we do not yet have the controls in place. So the worst case, unfortunate scenario also is, I hate to say this, but in education, what happens if you get lazy? You want a generation of students who basically simply go out and generate their work through AI and learn nothing. It's really a very, very concerning situation today. And universities, and I know, Mariette can speak to it well because the challenge in journalism is extreme. It's unfortunately a case where we could drive the dumbing down of the education system.
I mean, a way I would put it is it's hard enough. The technologies are complex enough. The world's problems are challenging enough that it's hard enough to get the world moving forward in a positive way, like the World Economic Forum always works toward. When you can trust the communication, now imagine that you can't. So yeah, that's a big issue. And at universities, I know many of us are really focusing hard on how to use these AI tools for good, how to use them to enhance our critical thinking, how to use them to extend humanity's capabilities, and not as some kind of way to cheat and hide things.
Here is an extreme case of the ecosystem not being remotely prepared for this. Not even remotely. AI has moved at a rate and pace that is absolutely terrifying. And if you look at the entire ecosystem, simply generating the power required to run an AI unit, to run the models, it doesn't exist. I mean, people are literally throwing up gas turbines right alongside the data center because there's just no power available on the grid. This is at the same time you're competing against trying to bring EVs online in quantity. And the ecosystem is not ready. And it is part of the reason we point to this is, we have to go now and deal with this issue. And it may be constraining AI. I'm not a fan of the idea, but there may actually have to be a throttle if we're not going to essentially bankrupt the power system. It's a very, very challenging situation we're currently in. But in the end, we have to find ways to trust what we're given. And this will erode trust.
There's also a business imperative that I think that isn't talked about enough, where your competitor could misrepresent you and they could say that this is your product and it's not, and that erodes trust in commerce. What is the role maybe for business leaders to sort of help kind of drive this along?
The good news is business leaders, frankly, are aware of these challenges. This is becoming a widely understood phenomena. And the challenge the business leaders are most worried about, to be honest, is not somebody misrepresenting them. The challenge is that IT and attacks thereof, hacking, it's still done mostly by people who are either A, expert at it, or B, download attack vectors off, for instance, the web from a paid service. Imagine if you turn loose a high-quality AI system generating new vectors of attack to take down the IT that runs everything. That is a nightmare scenario. And so business leaders are addressing this today essentially quite directly in terms of upgrading their defenses. And in terms of, frankly, if you go to RSA, which is sort of the security conference of the year, they're actually, all of them are talking about actively using AI to defend against this problem. That's sort of the really immediate concern.
We have a bit of a shift from AI to something that maybe not a lot of people are familiar with. Green nitrogen fixation. It's hugely important. I don't know that a lot of people understand that it is a $200 billion market already. But what is it for those who aren't familiar?
Yeah, so plants, of course, do this naturally. They take nitrogen from the atmosphere, N2, if you remember your high school chemistry, and they break it into components that they can then fix into plant metabolism, and ammonia is the main compound that they use to create it. About 100 years ago, humans came up with a way to amp that up called the Haber-Bosch process, which today, provides helps us all feed the world, but it takes a tremendous amount of energy. It's probably 1% to 2% of the entire globe's amount of energy. Talking about AI and computing systems, this is another large energy drain. What's required in that process is temperatures north of 400 to 500 degrees Celsius and atmospheric pressures more than 150 times what you and I are experiencing right now, 130 to 150 times. So you can see it's really energy intensive. But what if, turning to our, to our different ways of doing things, what if we could get that conversion to happen either through organisms or through other mediated processes? One is the use of lithium to mediate the chemical changes that are required to fix nitrogen. And another is, again, to engineer some organisms, particularly bacteria or their enzymes, to help fix nitrogen. And there are companies working on both of those. So huge impact. Maybe not the sexiest thing, but I think we all like to eat and we all like to make sure our food is arriving in a continuous way. And this technology, or both of the ways that they're going about it, have other advantages too. For instance, ammonia is a really great way to carry around your hydrogen instead of trying to do liquid hydrogen, which requires a lot of energy to make sure it doesn't escape. We all know hydrogen, lightest element in the universe. It loves to escape from things. So it's a better way to carry that. Also could potentially be used and is being set up to be used as replacement for diesel fuels in some marine applications.
And also in this big picture, it also will kind of maybe reshape agricultural supply chains. What would that look like?
We've been talking a lot about distributed opportunities here. So now today with the Haber-Bosch process I just described to you, highly energy intensive, lots of atmospheric pressures. Obviously, you can't do that everywhere, equally around the world. We don't all have the capabilities. But if you can make it into either mediated processes that are simpler, like the lithium one, or using organisms that are engineered, you can then distribute it like some of the other technologies that we talked about and get all of those advantages. Less trucking it around, less energy required to do so.
Mm-hmm. And there's plenty of efforts that are already in place with all this. But, what maybe are clouds on the horizon? What could slow this down?
Well, anything new is always going to be a challenge. Although in this case, I think the challenge will be more physical than regulatory. And I think it's a matter of scaling across borders.
And our very last technology, it is nanozymes, which are very, very interesting. And they're nature's catalysts for health. They're replicating nature's catalysts for health and environmental breakthroughs. So let's talk a little bit about that. It's already a $5 billion market, and it is set to grow to $60 billion in the decades ahead. What are nanozymes? A little bit more, and how do they work?
So you've heard the word enzyme a lot in our conversation over the past hour today, and enzymes are needed to accelerate various chemical reactions. But one of the things about enzymes that are produced by nature is that they are limited by the things that nature can live in. So in high pressure, high temperature situations, they tend to break down a little too rapidly. But if you can, and when I add the word nano, I love the word nano, but nano just refers to the size of the molecules. So we're talking about chemistry here. When we say nanoenzymes, these are, rather than produced by biology, they're produced in the lab. And as a result, they last longer, they can endure more challenging circumstances, and that means that you get the benefits of that. When you can reduce costs dramatically, when you can get something that lasts longer so you need to make less of it, when you can distribute it more easily because it doesn't have to be all, centrally done necessarily, get lots of benefits. And it sounds like we're echoing a real theme here, Bernie, through the entire report this year. It sounds familiar. But I think what's amazing is how these technologies, if you think about them, they might sound like 10, but they're also unlocking so many other potentials for humanity.
The report mentions that there is an opportunity that it will kind of change how research is done, but it can also sort of help dissolve boundaries between different disciplines. Can we talk a little bit about that and how that's useful for folks in the sciences?
Yeah, I'd like to turn to Bernie in a minute because he is an actual scientist as opposed to me, who's just a science voyeur. But I think the nature of all of these technologies is they do need to work across disciplines to be as successful as they can be. You need different disciplines interacting at the beginning. We need to build bridges. Sometimes scientists and technologists in one area and another don't even use the same terms. So as we learn to work in a multidisciplinary manner, as these fields converge and new innovations arise out of them, I think there's only a benefit to that, but it is harder to do.
And it is, very few of these things we do nowadays can be done in a vacuum. In fact, what's kind of interesting is what I call the soft and hard sciences are really becoming indistinct. In other words, I'll give you an example. When you're talking about AI, there's an enormous sociological factor in its utilization, as well as, of course, the technology behind it. And you have to have both working together for it to be effective. Remember that what has made things like ChatGPT and Gemini and all of the other AI instantiations impressive is that they can communicate naturally with people. That's a sociological issue. That's a sociology. That's not driven just by a bunch of geeks who go off and write great code. It takes all of them. So you really have this wonderful thing where communities nowadays get things done. It's no longer done in a vacuum. There was a time when science could be practiced discreetly. But if you want to have a tremendous societal impact that's for the good, it really takes this fellowship across many disciplines for that to work. And it specifically requires you to engage people who understand how to work in a societal setting, not just in a laboratory. And the things that fail miserably, by the way, are the ones just in a laboratory, because when they get out in public, people look at it and go, huh?
You mentioned that, hey, people need to be thinking in a societal way and all this. As we have looked at all of these technologies, and we've been trying to make sure that we keep the long term in our sights as we do this, it's really, really hard. We mentioned that most people think about the short term. Most business leaders are thinking quarter by quarter, if that.
Oh, there's a famous phrase, obviously I've worked in technology my entire career, which goes back many, many decades. We'll just leave it at that. After a while, because I've seen the hype cycles, you just get tired of it. And so I have a simple phrase that I use, which is data wins. Please, Lord, do not bring me your theory if the data says X and you're yelling Y. That is getting lost. It's a tragedy, because what happens now is people who have absolutely no knowledge, whatever, because they can amplify their voice so wildly on the web and elsewhere, it's become a force, unfortunately, for evil, to be honest, where if you have an opinion which has no basis in fact, you can nonetheless make it sound very, very real. And so the key thing people have to remember when they're looking to avoid the hype is data wins. If you hear something that says that, this doesn't work, there's no effective vaccine, data is that 300 million people died of polio in the 1900s, and since then the number on that scale is 0. Well, okay, that's data. You can have whatever opinion you want, but it doesn't change the data. And that's one of the ways around the hype cycle, is you force people to talk about actual facts with data behind them. So that's one of the things. And the other things is just be careful what your source is. A refereed journal, like it or not, is someplace that 10 experts have looked at something and said, yep, it meets the minimum criteria for reality check. And unfortunately, in the instance of the web, there's no reality check. The reality check is how many hits can you get and how much money can I make, independent of whether it's true. And it's very important to know the difference. And one of the more interesting things you're seeing today is they're looking to actually take away the web access at a young age where you're not yet equipped with enough knowledge to sort things. And they're treating it very much, interestingly enough, like drinking, where there is a responsibility to society to actually know what you're doing before you act on something. And so it's a very great challenge, because you have to be careful. You don't want to get into the area where it's censorship. But it is very important, particularly among leaders, to really force that issue around data wins, because that dramatically shortens the hype cycle.
Mm-hmm. And Mariette, in your mind, what should leaders be thinking about? What questions they should be asking themselves to help them think better in the long term?
I mean, one thing, I love what Bernie was just saying about data, and I really celebrate the idea of an evidence-based mindset and thinking carefully about what's there. But, because leaders are so busy and because they don't have all the time in the world to do that, I suggest that they also look to trusted sources. Bernie mentioned journals. I would also talk about conveners like the World Economic Forum, who bring together the experts in the world and produce rather concise reports of complicated issues. You don't have to be intensively investigating on your own for hours and hours every day. Other people do that. Find the right ones through trusted sources and take advantage of them. And then, have the conversations that you need to have with the audiences you need to have them with, whether they are colleague businesses, policy leaders and regulators, or the communities that the research is meant to serve.
Yeah, there's the community I'm part of. I've been part for years on the board of the STS Forum in Japan. STS stands for Science, Technology, and Society. And the Professor Omi, who founded it, has a very interesting theory, which is simple. There are lights and shadows to every technology. And for crying out loud, pay attention to both. And it's really what we're talking about here. That's exactly what your question is, which is there's things you're going to do that are of great value. And I celebrate the progress in AI. Let me be very clear. It's an incredibly valuable tool. But misuse, like any other technology, it is hugely problematic. And it's very important to have that balanced view. And again, it's just a bunch of experts who get together for a week in a year and look at those issues. So you don't have to do it all yourself. But be open to participating in the WEF, in STS Forum, and many in RSA, and in all of these forums where the experts will do the work and will net it down to something that is quite consumable. You don't have to do it yourself, but you should be aware of it.
And business leaders, as you mentioned, Mariette, who are very, very busy, and maybe they're not experts in all this, how useful is the very simple question of what's the before and after? What will happen a decade from now, a generation from now? How useful is that as a question, just as a gut check for folks?
I think it's useful. I also think, any good business leader is thinking about what success looks like. I think one of the other keys after what does success look like is making time to think about it. How do you get there? What are the tools we need? But yeah, a before and after analysis is always useful.
Of all these technologies, what excited you both the most? What did you like?
Oh, it's like you're asking me to pick between my kids.
You have a favorite even there.
I was going to say.
Yeah, I don't know. I'm going to make a general comment on that, which is I love how this year, especially, they are very integrated and they build one to the other. And that's another theme that the report mentions, which is that, you mentioned at the beginning, we look for weak signals that, in the noise to find out what's going to advance. But what the other effect, in addition to, signals that we're looking for, is that these things tend to build. Shoulders of giants and all that. And so what I'm really excited about, if I look at the entire package, how neatly and amazingly it fits together. Human ingenuity is just spectacular.
About yourself, Bernie?
I have a similar view of it. If you think about it, when you look at, for instance, any of the ones that we spoke of, for instance, collaborative sensing. Well, imagine the impact that has literally across all the other things I spoke of. Whether you're talking about, it's collaborative sensing. How do you know the data that you're getting is real? Well, guess what? Generative watermarking actually helps you as one of the elements to determine it's real. Similarly, if you're worried about nuclear power, remember that an AI-driven system can look at virtually everything happening in a reactor environment and in a power plant almost on an instantaneous basis. And it does that through, imagine this, collaborative sensing. So, they're not distinct in the sense that they're not connected. Actually, what makes them so powerful is they are connected. And so it's not a favorite per se in any one of them, but it's how some of them play together as that particular group I cited that really is foundationally differentiating long term. And that is actually of great value.
Bernie, you mentioned a little bit about data and sort of understanding what the what is becoming harder and harder. But with all of these technologies, what kind of gives you guys a little bit pause? What keeps you up at night?
For me, it's less the technologies themselves and the fact that we might let them sit there and not take advantage of them. I do worry with our rather fractured communication ecosystems these days, with ongoing challenges of polarization in different areas of the world, that we're going to leave some opportunities unexplored, and that's what really bothers me at night.
My greatest concern is that we're at a tipping point. AI is a fantastic tool of immense value, and I firmly believe it will grow and continue to be spectacularly important. Here's the challenge. AI is not inherently intelligent, in spite of the word. What I mean by that is it learns, and it does a pretty damn good job of learning it and expressing it by looking at what's out there in all manner of documentation, the web, and you name it, and then, of course, comes back with an integrated view of what it saw. The challenge is it still is driven by the weight of numbers. Human intuition, unfortunately, isn't there. So that if the weight of numbers say that something is X, and yet there are 4 people out there who have shown conclusively with hard data, it is not X, it is Y. Every time it's going to come back and tell you that the answer is wrong, is X. It will ignore the Y because there are 30,004. It's just how that works. And they have not come up with that. And I worry that we are undervaluing and not protecting that human intuition. We need people who will look at the great depth and look across things where they are suspicious that there's a problem and fix them, because AI is not in the current state able to do that. So I don't want the dumbing down of the scientific community by becoming reliant on what amounts to a fantastically effective and intelligent search system that can express itself very convincingly as to something being the case where, in fact, it is not. And so this is a real challenge. How do you strike the balance? Because it's a great tool, but it's a tool. It is not a substitute for the human brain. And that is a very, very tricky balance that we have to strike. And that does keep me up at night.
You both have been amazing so far. You have one last question, and then I release you back into your lives. What gives you hope with all the things we've talked about today?
So you can hear I'm the techno optimist here because I don't know as much about it as Bernie, the researcher. But what science gives me hope. I love our endless attempts to understand how the world works, whether it's near us or far from us. Sometimes it takes a long time between discovering an insight, like Einstein's general relativity and special relativity, which now we use every day in our phones for our GPS, right? We realize, so that took how many decades? So sometimes we don't know what it's for, but it continues to happen. I mentioned before, I'm just really excited about human creativity. That gives me hope.
What about you, Bernie?
I'm going to be honest, what gives me hope is sitting here. You have to understand that the very fact that the forum does this and supports it with an enormous amount of effort. I mean, people who read this should understand it is not the two of us. Let me be really clear. There's an enormous team that did this. That gives me hope because they still give a damn. Okay, they're working on it. They understand the importance of doing it. And it's not unique. If I look around the world, like I said, the SCS Forum's another example, RSA, there are lots of great organizations out there that their people are driving it. An organization doesn't do a damn thing. It's got a heading and a tax bracket. But the reality is there's still lots of people out there who understand how vital it is that we have these discussions and share these concerns and address them. And, governments may not always be the finest example of how you deal with it, but it hasn't changed the fact that you have universities, you have organizations like the WEF, they're out there doing this, and there's thousands, actually hundreds of thousands of people involved in it. So it's not that all is doom and gloom, not the least. The very fact that we could find 10 things we look at and go, wow, or if you go back over it and you look at mRNA, and look at CRISPR-Cas9, that gives one hope, because these came about because these very organizations drove the findings. And the findings had profound global impact. I sat there, 5 years after we identified mRNA as the next big thing for vaccines, and I got my shot, my COVID vaccine, the first one, and I'm sitting there going, we got that one right. And again, it's not us. It's this team of extraordinary individuals. And the very fact that there are people out there who care enough to do this and organizations that care enough to support it, it gives one hope that it's not even that all is not lost, but in the end, in spite of various strange things that occur along the way, this, in the end, will win out. Putting it another way, as I always say, data wins. In the short term, maybe not, loud voices and ignorance, but in the long term, data wins.
I love it. Well, thank you both for being here and giving us a little sneak peek at how our world might be a little bit better.
Thanks for having us.
Thanks for having us.
Thank you. And for more episodes of Radio Davos, please go to our YouTube channel. And for more transcripts, go to wef.ch/podcasts.